You're watching the free version of SynthEyes Essentials. For projects and footage, head to BorisFX.com for the premium download. Hey, and welcome back to the second part of object tracking in SynthEyes. As we figured at the end of the first part of this class, we are going to need to establish some proper constraints for our scene. Before we can do that, however, let's do some prep work and color our trackers. With the camera being my active tracker host, I can now quickly go through and color the field, the road, and the tree in different colors. The tree will be particularly helpful in defining the proper position of our car. I'm going to select Object 1 as my active tracker host and select Hole to move both the trackers and the object. You know, the moving diamond that was added to the scene at the beginning? With Hole activated and the scale tool selected, I can now change the distance between the object and the camera. While not that much is happening in the perspective view that is locked to the camera, a whole lot is happening in our three orthographic views. We can now really bring the car object closer to the camera. It's a shame that we can't see the colors we just set up. Well, actually we can. Just change to the camera as the active host. As long as we are still modifying the object up here, we are happy campers. So now we've got the colors of the tree as a great indicator. I can take a look in the locked perspective view, see if the car is passing the tree, and then adjust the distance so that my point cloud matches up. There's just one little inaccuracy here. If I'm zoomed out too far, it looks like my manual trackers are below the orange point cloud of the street. That actually isn't the case, and we can see that if we zoom in. What is happening is that manual trackers, by default, have their names displayed in all views, but in this case, this kind of works against us. So let's switch that off by right-clicking and deselecting Show Names here also. Now that's better. You might have noticed that our object has got a pretty big axis in the locked perspective view. That's a little tease that the object has got its own dedicated coordinate system. That actually makes a lot of sense, because we will need to be able to stick reference geometry to that moving object. And like with the cube on our chessboard, we will want that to be as convenient as possible. We will also need this coordinate system later on to establish a proper scale to our object. So by changing from world to object, I can call up the object-centric coordinate system. Let's press 8 in each of the orthographic views to frame them up. As the camera is still the active tracker host, this is right now centered around the camera, but if we change the active tracker host to our moving object, we now see that little diamond at the center. Note that this origin point is not the origin point of our entire scene, but its own origin point for the object. The point cloud of the scenery moves around the object's origin point. In the beginning, this might be really confusing, but play around with it and you'll get used to this in no time. So now we can align this with the center of our point cloud. I want to mimic SynthEyes behavior and have the origin point near the bottom of our object, because that will make drawing primitives much easier. So let's just do that. It might not exactly look like a 2009 Jaguar XJ6, but a box will do just fine. Draw it up in the middle of the object's coordinate system and scale it to fit the point cloud of the car. With that being done, let's align our world. We have a very uneven road, so something like the *3 method will not do. Still, I want to have all the points that are colored magenta near the ground plane. Right now, our point cloud is so far away from the ground plane of our world that we don't even see it in the locked perspective view. We could use our tried and true method of manual alignment, but I want to show you a nice way of automating this. In the floating hierarchy view, I will select all the trackers that are colored magenta and are hence associated to the ground. Then, in the locked perspective view, right-click and go to the grid menu. There you can select to faces, vertices, trackers, and a grid will appear. Now this is not the ground plane, not yet. It is a working grid, and you could use it just as a guide to align things. But if we call up the grid menu once more, we can select Make Grid the Ground. Using the 8 hotkey to frame up our orthographic views again, we can see that we are almost there. It's just a matter of rotating this in the top view, and there we go. Note that the object moved along when we repositioned the world. However, when we adjusted the object's coordinate system, it had no influence on our world. That is because the object is a child of the camera. If we open up the floating hierarchy view once more and collapse the trackers, we can see the camera sitting atop in this hierarchy. This will be a bit of an issue when it comes to introducing distance constraints. So far, we've only worked with a relative scale, so we were able to position the car near the tree. One challenge in this scene is that the only object we've got proper measurements for is the car. But if the object is a child of the camera, then we cannot really scale the scene to fit the object. If we introduce any distance constraint to just the object and then do a refine, we are going to break that relative relation. We will have to resort to some lock point magic to get this to work. So far, we don't have any constraints on neither the scene nor the object. Let's change this and start by establishing a distance constraint for the car. The car is quite curved, so I'm a bit hesitant to use any of my existing trackers for a distance constraint. But a quick Google search tells me that the wheelbase of this car is 3.034 meters. With the object being the active tracker host, we can now track the center of both wheels. Zero-weight trackers will not work for constraints, as they do not get passed on to the solver. But as I don't want to mess up the good object solve we already have, I'm going to lower the weight of these trackers to 0.1. Now let's go to the solver room and refine the track so that our solved points become available. The coordinate system of an object behaves almost exactly like the coordinate system of a scene, so if I refine this now with just a distance constraint, I will mess up the manual alignment I made of the little diamond in the middle of our point cloud. Let's realign this once more and let's select some additional lock points here to keep this in place. With the distance constraint and the lock points, I once again have a properly aligned coordinate system for my object, but now with a real-world scaling. As expected, the distance constraint broke my relative alignment with the scene. To bring the scene to the same scale as the car, we are going to the beginning of the shot and select a couple of the magenta trackers on the gravel road, close to the base of the car. As we already broke the relationship, we have only got our camera view to go by. In the trackers room, we can now turn these into seed points, and by clicking this little plus icon and dragging the mouse, we can do the same thing we did before when scaling our scene in relation to the camera. Pull these out until they are roughly below the distance constraint of the wheelbase. If you are happy with the position, turn those trackers into lock points and go over to the coordinates room. Do you see the huge mismatch between the solved position and the locked position? The solved position is of course where they are now, but as they are locked to these points, a refine will realign the whole coordinate system to fit with these few lock points. So let's see this in action. Let's refine again and there we go. As we used lock points, we are still able to center out the scene. So I will repeat what I did before and select all magenta trackers from my floating hierarchy view, use them to align my working grid, and make that the ground plane. And as the car is a child of my camera, it moves along beautifully. And now it's time to prove if the real-world scaling really works. If we didn't mess up, this car should be 4.92 meters long, 1.86 meters wide, and 1.44 meters high. This doesn't look bad at all. Would we have had somebody on set who could have taken measurements of both the car and, let's say, the width of the gravel road, then this process could have been a little bit more straightforward, with us just providing distance constraints for both coordinate systems. But the truth is that a lot of times we don't have this luxury, so I wanted to show you how to deal with this issue in less than ideal circumstances. Let's take a final look at our scene. We can see that the car is driving right along the gravel road as we colored those trackers magenta, and with the box in place we can see that it stays right on track. Let's also see if our constraints are working. I'm going to switch on the tracker radar on my object trackers and fine-tune these a bit. As I spend a lot of time manually tracking these in, I don't want to brute force this by using the cleanup trackers dialog, but rather, I deliberately go in here and deactivate individual trackers when they go bad. And let's refine. Everything stays locked in place, but both error curves are in the green. Let's recap what we've learned about object tracking. Both the camera and any object in SynthEyes do have their dedicated solvers and coordinate systems. Each of these solvers can be fed by automatic as well as supervised trackers, or a combination of both. The object you solve has got its own dedicated coordinate system, but is still a child of the camera and its coordinate system. The distance relationship between camera and object has to be provided by the artist, either relatively by eyeballing it, or, even better, with on-set measurements to introduce a real-world scale. Okay, we did pick up the pace quite a bit in this class, but as this was mostly a recombination of the techniques we learned previously, I think that's appropriate. If anything is unclear, just take another look at our previous classes. In the next and final class of SynthEyes Essentials, we will take a deep dive into export, so that you can make sure that all this valuable data you created gets properly loaded into the next step in your VFX pipeline. So take a little breather, and I will see you there.